The topic of electrostatics is generally just looking at static electricity. So there's a few different examples of static electricity that you've seen in your everyday lives. And we're going to talk about why that occurs and how that works in the course of this unit. So a few different examples. First of all, in the wintertime when you're walking on a carpet in your socks and you go to touch a doorknob, sometimes you get shocked on the doorknob. That's because of static electricity, electrostatics. Another example is if you were to take a balloon, and if you take the balloon and rub it in your hair, then you can stick the balloon onto the wall. I know most of us have done that at some point. That's also electrostatics, static electricity. And the third one is lightning. Lightning and thunderstorms is another fundamental principle of static electricity. So this video, I just want to give you just an introduction to what causes electrostatics. And it's a really important video because you need to understand why electricity actually works. So this is not just about static electricity. This is really about electricity in general and the principles behind why electricity occurs. So first of all, if you remember from chemistry, you have an atom, and inside the atom you have the nucleus. And in the nucleus of the atom we have neutrons and we have protons. Now, I'm not really going to worry about the neutrons. The neutrons have no bearing whatsoever on static electricity, so I'm only going to draw protons. So let's just say that this atom here has 4 protons. So we have four protons in the nucleus. We also know that the atom itself has the different valence shells. So the first shell, we have 2 electrons in orbit around the nucleus. The second shell, we have our 8 electrons. Typically, if it's a full shell, we have our 8 electrons around the nucleus, so it's supposed to be a pretty decent circle. And we know from chemistry that bonding occurs when you have an absence of electrons, or basically an excess of electrons. You have the electrons that actually move between the atom, from one atom to another atom, and that's how you have your bonding. That's how you form molecules. And so what happens in electricity is kind of the same thing. We're talking about the movement of the electrons. The protons themselves are bound inside the nucleus of the atom. So the protons are not going to be able to move. They're stuck inside the nucleus. It's the electrons in the outer shells. That's what's really going to be able to move around. And that movement that we have causes our electricity. So really everything that we're dealing with here involves the flow of electrons. So it's the flow of electrons that's everything. Now, the other thing we're going to have to talk about are charges, because we have 3 different types of charges. We have a positive charge, we have a negative charge, and we have a neutral charge. So if I look at just 3 different objects, and I'm just going to draw them as spheres. They don't necessarily have to be spheres. If we have a positively charged object, it means we have more protons than electrons. So inside this atom, you might have, let's say, 5 different protons. Let's just say we have, I'm not going to worry about drawing the electrons on the outside when I'm drawing these. Let's just say we have 3 different electrons with the atom itself. So we have more protons than we have electrons. That's what gives this a positive charge. It's important to understand that a positive charge does not mean that something is devoid of electrons. It just means that we have more protons than we have electrons. So it has a net positive charge. There's different types of positive charges. There's different levels. You can have a very weak positive charge where you have not much of a difference between the protons and the electrons. You can have a very strong positive charge where you have many more protons than you have electrons. So the strength varies on the difference that you have between the different charges. Same thing kind of occurs with the negative. When you have something that's negatively charged, it means you have more electrons than protons. So if we have just those 5 protons we had in the previous one, we just have more electrons. What's important to understand here, really, with positive and negative, in order for something to become positively charged, it means it loses electrons. In order for something to become negatively charged, it gains electrons. The protons aren't going to move. So the protons remain here, kind of like what I was saying earlier. They're bound inside the nucleus. So you're just adding or subtracting electrons, and that's how you get your different charges there. So for negatively charged, we've added some electrons, so we have more electrons than protons. Then neutral, we have the same. So if we had 4, or let's say 5 protons, we're going to have 5 electrons as well. So the electrons, I should say the number of electrons equals the number of protons. So in order for something to be charged, and I have different videos that describe different types of charging, in order for something to be charged, it's all about the movement of the electrons. So this right here, flow of electrons, that's all that matters. You can positively charge something by removing electrons. You can negatively charge something by adding electrons. You can neutralize something by either adding or removing electrons depending on what the original charge was in order to balance out the charge. But it's always about the flow of electrons.